Good morning. Week 6, lecture 1. So it's a new topic. We're going to be starting off with this topic called binomial theorem. Okay, so we're going to be learning some properties of factorials, permutation and combinations, and then finally binomial expansion using binomial theorem. Okay, so what is pi? I think we already know. Pi means 2 and nomial means terms. So binomial means 2 terms. So we are dealing with terms up to 2. So, okay, moving on, a factorial. So this is going to be a new operation. It's called a factorial. So a factorial function is defined on natural numbers only. This is for your level. On another level, you're going to be using factorials not on natural numbers, but for this case, or your level, we only define on natural numbers. So for a given natural number n, its factorial written as n factorial. So this sign here, the exclamation mark sign, in maths, particularly this topic, it's called factorial, and this is called n factorial. It's the product of all natural numbers between 1 and n, inclusively. So the wingangal operation leo, the operator leo, or the product. Products, we're dealing with multiplication. Okay, so for example, if we have n factorial, expand, this is using variables, so that's n, and then you multiply with n minus 1, multiply n minus 2, multiply n minus 3, and so on until you reach 1. Okay, so example, we have 5 factorial. That means 5 times 4 times 3 times 2 times 1, which gives the answer of 120. So the operation niya 5, sige amakamel 5. Afakele lola ayalong ilalo numbers. So you start from 5 and you multiply, and then you minus 1 from 5, you get 4. You multiply minus 1 again, you get 3. Multiply minus 1 again, you get 2. And then you multiply minus 1 from 2, you get 1. And remember, it stops at 1. And you multiply this using your calculator, that's 120. Or this simple here is on your calculator as well. Just press 5 and this simple, and just press equal, and then you should get 120 as well. Same with 9 factorial, that's 9 times 8 times 7 all the way up to 1, which gives the answer of 362,880. So also try and use this simple on your calculator to see if it gives the same answer. Okay, so there are some special cases. So for example, 0 factorial, that's equals to 1. And expanding factorials, this is the formula. So so we start from n, so and then you minus 1, minus again. You are deducting 1 step by step until you reach 1. But if we use a variable such as n like this, you don't have end. You keep on deducting 1 until you reach, I don't know, infinity. Until we get the value of n, then we know where to stop. Okay, some properties of factorials. This is a property like n factorial, that's same as n multiplied by n minus 1 factorial. So this is not a property. You cannot distribute the factorial in like this. So n times m, bracket factorial, that's not the same as n factorial times m factorial. And this is also applies to addition. You cannot distribute. And also with minus. So please be aware that factorial doesn't follow the standard rules of addition and multiplication of numbers. Okay, let's do some simplification of factorials. So 8 factorial divided by 5 factorial. So solution, so 8 factorial divided by 5 factorial. You can either expand everything out and then you cancel the common ones, and you're left with 8 times 7 times 6, which gives you 336. But there's a shortcut where you expand only the factorial that is greater. Only 8 factorial is bigger than 5, so you only expand the bigger factorial until you reach the smaller factorial. Because if you expand 8 factorial, it'll 5 factorial. And and you stop here and you put the factorial, and then you can simplify the two, giving you the same answer of 336. Okay, same case with this. I either expand everything out and then just simplify the common ones, like this, and I get the answer of 66, or I only expand up to 10 factorial, because okay, Lord, 10 factorial is inside 12 factorial. So if you expand 12 factorial, you get 12 times 11 times 10, and you stop there, then you put a factorial to stop it. And now you can simplify the 10th factorial, leaving you the same answer of 66. Okay, what about dealing with unknowns? Same case. We expand the one that is greater, or the bigger factorials. So this n plus 1 is bigger than n, so we expand n plus 1 factorial. So we also start from n plus 1, and then you minus 1 from n plus 1, you get n. Stop ruling, because now we have same denominator and numerator here. We can cancel that out, leaving us with the answer of n plus 1. Same with this one. Which one is bigger? Is it the numerator or the denominator? Obviously the denominator. Because ole minus 1e. Yeah, e say minus 1. So you expand the one at the bottom. So you minus 1 from the bottom. Then you simplify, giving you the answer of 1 over n. Okay, so please pause the video and try and attempt this class activity. Post the ILO video. Solve these ones, and then you can check the answers later. Okay, moving on. We're coming to this other subtopic, which is permutations and combination. Yeah, or combination in English we use it but in maths there are specific rules that follows permutation and combinations. Like for example, a fruit salad is a combination of apples, grapes, and bananas. We don't care about the order of fruits. Because if I say fruit salad, we call it combination because we don't care about the orders. Apples ole basket, grapes bananas. Ele matter order. So that's why we use combinations. But for permutation, the order matters. So for example, a combination lock for so that's technically not correct. It should be called permutation locks. Because ole permutation, the order matters. So for example, if the password locate phone, if the password of your phone is 1834, so a metal order, the order should be 1, long rule 8, long rule 3, long 4. So I didn't think I can miss around your numbers nga makala locate phone. So same with locks. So we use permutation when the order matters. Okay, some keywords. When the order doesn't matter, it's combination. Okay, so here's a formula for permutation. So this is called NPR or NPIC-R. The formula n factorial divided by n minus r factorial, which means if the number of permutation of n items taken from r items at a time, for example, NP3, that's 3 factorial divided by 3 minus 3 factorial, which is 3 factorial over 0 factorial and more 6. So that's the the permutation formula. Combination formula almost the same, but we add an extra r here. So this is NCR or N choose R. In same case, if you have 4 items and you're choosing 3, how many ways? Apply for the formula and get the answer of 4. Okay, so for example, how many ways can we rearrange the letters A, B, C? Okay, so if I arrange for C, A, B, P, A, B, A, C, B, C, A, C, B, A, and A, C, B. Arrangements. So because the order matters, so we have 6 permutation. 1, 2, 3, 4, 5, 6. And for combinations, because for combination, ele metal order. If combination looks like this is the same as this is the same. It's just that they are using different letters, but we letters. So permutation or combination or kasi. Okay, another example. Consider the four letters. Let's choose two of the four letters. In how many different ways can we arrange two of the four letters? And how many different ways can we combine two of the four letters? Okay, so we have A, B, C, D. Ika ko wala I. Lumo kong fa yung mai. A, B, A, C, A, D. B, A, B, C, B, D. C, A, C, B, kuso leke kang so fa pi fa kasi letters se lu fo ngai A, B, C le. Okay, so for permutation, if you count all these groups, it's 12. That's permutation. But for combination, we eliminate the letters like repeated, even if the order is the same. For example, we have AB, therefore we don't count BA. We have AC, we don't count CA. We have AD, we don't count DA. We have BC, so we don't count CB. We have BD, we don't count DB, and we have CD, therefore we don't count DC. Because the order doesn't matter, therefore combination ng yung. Because ele counting nga letters here nga lingal fili wa iya kulang. Ele count ele combination. Okay, so example for ang formula. So we have four letters and we are picking two. So we have four annual four, but we are only picking two. So R2 sub formula, and if you do that in the formula, apply formula, we get our answer of 12. Also on your calculator, you should have a P. It is simple little P on your calculator. You can press the P, like 4P2 equal, and you should get 12. Okay, combination, same thing. You also have a C on your calculator. So if you press 4C2, you should get the answer of 6. Okay, so like always, please try and do these class activities by yourself before continuing on. So these are the answers and your homework. So please do the homework. This is going to be similar with the one that come in your test 2, which is in week 7. Okay, that's the end of our lecture. I'll see you when I see you.